In this video, we're going to review some of our properties of logarithms, and I have a nice chart here that kind of applies all of, or shows all of these properties of logarithms. Now, the thing to remember is, remember that logarithms are telling you exponent values. So something that can really help you try to remember your properties of logs is think of everything in terms of exponents when you're looking at logs. So logs are equaling exponent values. So I add logs. I can have two logs adding together. So we're thinking about exponents. So when do I add my exponents? When I multiply like bases. So if I have multiplication inside of the log, I can break it up as two logs adding together. Likewise, since logs are representative of exponents, when do you subtract your exponents? Well, I subtract my exponents when I divide like bases. So if I have division inside of the logarithm, I can rewrite it as two logs subtracting to one another. And another very common one is if you have the exponent inside of the logarithm, you can write it out front as a coefficient multiplying to the log. And we'll get to the change of base towards the end of this video. So I want to start by condensing. Now, the process of condensing is the most common property of log, or set of properties of logs, that you will encounter until you get to calculus. I will condense logarithms so that way I can solve them. If you're in calculus, you will expand them so that way the processes like finding the derivative become much easier. All right, so the way I start this is you take all coefficients that you have, and you're going to take the coefficients and make them the exponent of the inside. Now, the problem is what about this division by 3? And so it may be helpful for you to remember that if I am dividing by a number, in this case, I'm dividing log base 3 or y by 3, it's the same thing as multiplying by the reciprocal of that number. So I'm really multiplying by 1/3. Now I can take all my coefficients and I can make them the exponents. So I have log base 3 of x squared plus log base 3 of y to the 1/3 power, which is really the cubed root, minus log base 3 of z. Now, what we can do is we can condense everything inside of one logarithm. So I have log base 3 of. Now, because I have the minus here, I know that something's going to be dividing. What's going to be dividing is everything behind the minus. So I'm going to be dividing by z. And what z is dividing into, because I'm adding two logs together here, is going to be the product of y squared and y to the 1/3 power, or x squared and y to the 1/3 power. And notice that I had to keep this base, log base 3. The properties of logs only work if you're using, or if you have logs with the same base as adding or subtracting with one another. Let's look at another one. So I want to condense all this inside of one logarithm. So quick base check, everything has base 2, so that way I can use my properties. We're going to take all the coefficients and put them inside of the log as exponents. So I have log base 2 of z to the 5th minus log base 2 y to the 10th minus log base 2 x to the 15th. Now I'm ready to condense everything inside of one log. So I'd say log base 2 of inside of here. Now we have two logarithms subtracting. So I know I'm going to have division. Z to the 5th is positive. That log's positive, so z to the 5th is going on the top. I'm subtracting the log base 2 of y to the 10th and x to the 15th. So that means they're both going to be dividing that z to the 5th. So I've condensed it into one log. Now, I could go one step farther and simplify this because I have a common factor of my exponents. 5, 10, and 15, everything is divisible by 5 there. So I could pull out a 5 and simplify that to be z over y squared x cubed, all being raised to the 5th power. Now let's go the other direction. Let's expand logarithms. Full expansion, so I only want to see a variable on the inside. I don't want to see any exponents or any operations, if I can help it. So start with this first one. Full expansion is if you see an exponent outside, apply it to everything inside of there. So I'm going to use my properties of exponents, and I'm going to rewrite this. I'm going to rewrite it as log of, we'd have x to the 6th, y to the 12th, power to power, you multiply your exponents, p to the 3rd, and z to the 15th on the bottom. now we're ready to break this apart. So we'd break apart, we'd have log of, we'd have x to the 6th plus log of y to the 12th, because the x to the 6th and the y to the 12th are times each other. Now, because I have p to the 3rd times z to the 15th in the denominator, I have to do subtraction for this division part. It'd be minus log of p to the 3rd. And the z to the 15th is also dividing the x to the 6th and y to the 12th. So I'd do minus a log of z to the 15th. And last thing left is take all coefficients and or all exponents and write them as coefficients of your logs. So it'd be 6 times log of x plus 12 times log of y minus 3 times log of p minus 15 times log of z. Okay, let's do another one here. So full expansion, we actually want to use the expansion properties to evaluate this ugly looking natural log problem. Now remember, ln is the natural log of x is a logarithm. It's a log base e. So all of my log properties can still be applied to the ln. What I do here is I do not plug in values yet, because the natural log of a is equal to 2. A doesn't equal 2, the ln of a does. Same thing with the ln of b. Ln of b equals 4, not b. Ln of b does. And the ln of c is equal to 6. So in order to put those numbers in, I have to do expansion. So just like what we did in the previous example, let's rewrite this problem and try to do full expansion. So I'm going to apply that exponent negative 4 to everything on the inside. That gives me a to the positive 8 power on top. Over, we got b to the positive 16. Now, I have this c. I got to figure out the exponent of the c here. Well, c is inside the cubed root. So I got the cubed root of c. Now, remember, the cubed root, same thing as c, in this case, c being raised to the 1/3 power. So 1/3 turned around, raised to the negative 4, and make to the negative 4/3, because I got to multiply them together. Okay, now we can break this ln apart and say, all right, this is going to make the natural log of a to the 8th power minus the natural log of b to the 16th minus the natural log of c to the negative 4/3. Make all the exponents coefficients, so we have 8 times the natural log of a minus 16 times the natural log of b. And then this would turn in, because when I pull that negative exponent out front, it's going to make that a plus 4/3 times the natural log of c. Now we can put in numbers. So the ln of a is equal to 2. The ln of b is equal to 4. And the ln of c is equal to 6. And then we'll simplify and evaluate from there. I'm getting negative 40. All right, now we're going to do a couple of examples where we're using the change of base formula. Now, the change of base formula you used to use all the time when you had older calculators that could only do log base 10s and log base e, so your common log and the ln. And now our calculators are fancy enough to do these logs and evaluate them and give you decimal values, in some case, for logs of any base. But the change of base formula is still important, especially when you get into calculus and some of the techniques that we have to do. We often have to rewrite logarithms to be in terms of the natural log, so that way we can do some techniques with them. So just to practice the change of base formula, if I want to rewrite a logarithm using the natural log, what you would do, so log base 2 of 4 is equal to, you apply your new log to the inside, so it would be the ln of 4 divided by the natural log of the base. So it would be the ln of 4 divided by the ln of 2. No, I cannot simplify that. There is no property to simplify the division of logs, because that's the change of base formula. And so that is my, those two are equivalent using the change of base form. Now let's do it again. So let's say I have the natural log of 10, and I wanted to rewrite the ln of 10 using the common log, which is really a log base 10. So the ln of 10, according to the change of base formula, if I want to apply my new log, which is the common log, I would take the common log, apply it to what's on the inside. So it'd be log of 10 divided by log of, and then I need to know what the base is. Well, remember, the ln is really a log base e. So I'd have log of e. And then we could actually simplify this because remember that the common log is really a log base 10. So log base 10 of 10 is equal to 1. So I could simplify that and say that's the same thing as 1 over log of e. All right, now let's make it a little bit more challenging using the change of base formula. Let's try to simplify this expression that we have here. And so I want to simplify the addition of these logs together. And in order to do this, we would need to rewrite everything to be in terms of the same bases. So your options are I could rewrite everything to be in terms of base 2, or I could rewrite everything to be in terms of base 3 or base 4, or even the natural log. That part does not matter. So I'm just going to pick one. I'm going to say, all right, let's rewrite everything to be in terms of base 2. So if I do that, I need to change the log base 3. So log base 3 of 24 would equal log base 2 of 24 divided by log base 2 of 3. And then I would need to do the same thing for the log base 4 of 24. So that would be log base 2 of 24 over log base 2 of 4. So log of the inside over log of the base. And then we're going to rewrite our problem. So we'd have 1 over log base 2 of 24 plus 1 over, we'd have log base 2 of 24 over log base 2 of 3. And then plus, we'd have 1 over log base 2 of 24 over log base 2 of 4. Well, we can simplify that. So we'll rewrite this, do skip, change, flip for those second two fractions. We'd have 1 over log base 2 of 24 plus log base 2 of 3 divided by log base 2 of 24. And then we'd have plus log base 2 of 4 over log base 2 of 24. Okay, well, now we can put all these things together and say, all right, so we can write this as one fraction. So we'd have 1 plus log base 2 of 3 plus log base 2 of 4 over log base 2 of 24. Now you might be wondering, well, how is this going to simplify? How is this going to help me out for this problem? Well, we're going to continue to use some properties of logarithms here. So first thing I'm going to do is I'm going to rewrite this 1. 1 is the same thing as log base 2 of 2. And then I have plus log base 2 of 3 plus log base 2 of 4 all over log base 2 of 24. And now we have our properties of logs. It says if we're adding logs that all have the same base, we could write that as one log where we multiply their insides. So that would become log base 2 of 2 times 3 is 6 times 4 is 24 over log base 2 of 24, which will reduce down and just make 1. Okay, now let's have another one. So this time we're given values for ln of A, ln of B, ln of C. And we want to evaluate log base B of A over log base C of B. And the way I would do that is since we have values for the natural log of A, B, and C, is let's do the change of base formula for this and let's see what we have. So I have this fraction. And so I need to do the change of base for the numerator and the denominator. Well, the change of base form, I'm going to use the ln. So my numerator would be the ln of A over the ln of B. And then my denominator would be the ln of b divided by the ln of c using the change of base formula. Now, what we can do from here is we could simplify this and do skip, change, flip. And so we'd have the ln of a over the ln of b times, flip the one that's on the bottom, the ln of c divided by the ln of b. And I'm just going to leave it like that because we're going to plug in numbers now. So the ln of a is 2. So I have 2 over the ln of b is 4 times the ln of c is 6 over the ln of b is 4. And then we just evaluate that. So we got 12 over 16. And that simplifies down to 3 over 4.